Yes, hello students. Here we have to discuss how to calculate the complexity of algorithm. Very simple. Just you have to learn how you calculate. First, we have to go through that one simple problem: how to find time complexity using the frequency count method. So in frequency count method, how to find the time complexity. So in an algorithm, you have to mention some command means if the execution time is zero. As assignment statement, condition statement, the running time is 1 unit of time. Loop condition and body of the loop. Loop condition will take n plus 1 times, but body of the loop execution time is n times. Okay, so you have to go through one simple example. Let us go to the first program to print the value of it. You get the input and you have to display how much time required. So consider some algorithm A async time, that's the initialization, that's the assignment. It takes a 1 unit of time. Next, we go to the next line, print A. Just you have to execute one time execution. So 1 unit of time. So f of n is equal to 2. So any value, it will be the order of 1. If the value is 2, if the value is 100, if the value is 1000, any value, the constant value, the time complexity is order of 1. So next to program to print 1 to n. Just you have to go to the program to print 1 to n. Here we are using a for loop. So the loop execution, so I assign 0 1 unit of time, I less than n, that is n plus 1 times, and I plus plus is n times. That means I assign 0 is an assignment statement, so 1 unit of time. I less than n is the loop condition, n times loop conditions. So n plus 1 times. That means here you have to print 1 to 10. First, if you have to print 1 to 10, once again increment, the 10 becomes 11. Check the condition 11 less than 10, the condition false. So here once again you have to check the condition, but not execute. But 10 time execute, but 11th time not execute. So that I less than n, it considers n plus 1 times plus I plus plus incrementation, repeated incrementation. So you have to mention as n. Next statement. So I less than n, I less than n. So you have to put from 0 to 1 to 9. So 9 time printer, that's the n time printer. So once again you have to find the complexity f of n equal to 3n plus 2. So order is hypernomial degree 3n. Like that the coefficient also, so you have to mention say yeah. Okay. Next, the sum of n natural numbers. Algorithm sum of a of n. As I send 0, for we are using on for loop. After the for loop we are using an array because you have to sum n numbers, so you are using array. Then you have to return the value. So you first go to the first value s in 0, that is a 1 unit of time. Loop n plus 1 times. Execution n times. Return 1 time. So you have to find the time complexity, big order of n. Order of n. Here the same program you have to find the space complexity. Go to the algorithm. Algorithm sum of a of n. A is the array, n values. N is the size of the array. One time execution. Yes, assignment operator. So here we are using one variable 1. So totally n plus 3. So order of n. This is a we have to find the complexity of algorithms. Complexity of algorithm. Next, you are using one loop state. This loop is not a nested loop. For loop, open the bracket, close the bracket. Another for loop, open the bracket, close the bracket. So if you are using the loop n plus 1 times, statement n times, another loop n plus 1 time, another is n times. So totally order of n. Next program, just go to the nested loop. So first loop n plus 1 time. Within the loop n times, statement n times. Another loop n plus 1 times, statement n So you have to multiply order of n square. N square time is execution. N square previous program n time execution. Here is taken n square time execution. N square time execution. Next multiplication of two matrix. First loop we are using n plus one time. So between inner body n times, another loop n times, or execution n times. Once again j loop n plus one times, n bodies n times, n times. Another loop k loop is there n plus one times, inner body n times. Calculate everyone. Answer is the n cube. So big O of n cube times here is execution. Okay. So next program. Similarly, next program you have to calculate for I loop I less than n. Here you are using a I as in I multiplication of 2. So 2 times you have to multiply. 2 times multiply here, not a single time increment or increment here multiplications. So 2 times you have to multiply. So you have to using assume the conditions and you have to stop the condition and you have to equate the condition, take log and both times conditions. So f of n is the big O of log of n, big O of log of n. So we go of log of n, sometimes the value is log 3, log 4, log 5, log 3, some 2 point something float values are available. So avoid that, we are using a ceiling value. Ceiling value. So the seventh program is a I assign I multiply 2. Eighth program I assign I divide by 2. So multiply means we go of log and time. Division also we go of log and times. We go of log and time they are execute. So multiplication, division they require less time. There's a less time. So next program we have to discuss. Here I assign is I assign 1, not here I less than or equal to n. Here you are using a p less than or equal to n, p plus plus plus. So instead of I, you are using a p. So mathematical expression you have to convert and k equal to root n times. So order of root n times. Next, go to the types of time function, order of time constant, log n, logarithm times, log n linear times, log n square, quadratic times, log n cube matrix, cubic time, 2 power n power n, and everything is exponential time. This is a comparison execution 1 less than log n more time to execution compared to log n is root n more time. Root n compared to n times n log n square. So less than so n power n exponential time it takes place. So these are the time function comparison. This is very important. How to calculate the time complexity, what is the complexity of algorithm, to find efficiency of the algorithm, why efficiency, how long time they require to run and store the data in the memory. So these are the complexity of the algorithm, to find the complexity. So next class we have to discuss something about the uh, worst, best, as well as the average case of the algorithm. Thank you, students.